Hi children, welcome back to the second session of physics class. In the last class we studied about physical quantity, fundamental and derived physical quantity, what is the meaning of measurement, then the meaning of fundamental and derived units, then the meaning of system of units, then the three popular system MKS, CGS and FPS, and the scientific system of unit SI. In SI, there are 7 base units and larger number of derived units. Out of many derived units, 2 derived units are important for us. One is called plane angle, its unit. We defined the ratio of arc length to radius is what we call as plane angle, and a mathematical equation that you might not have understood properly. This is related to something called differentiation in calculus, okay, which coming up in the next year. The notation I said you should read this as d theta equal to ds by r. What is d theta? It's a very small angle. ds is a very small arc length, r is the radius, and this is only a ratio. This is given a unit and the unit is called radian. Okay, we will come to the detail of radian later. Radian is written as rad. Okay. Angle is not in degree, important, it's in radian. Okay, this is what we studied in the last class. Now for today a little more detail. What is the meaning of plane angle? Plane angle represents two-dimensional space. What does it mean? Plane angle represents two-dimensional space. See, there is one line like this, another line like this one. These two lines are in the same plane, and the plane angle represents this space in between. In somehow, it's not the exact representation of it, but it represents that space in between. If the angle increases, there is more space. Angle decreases, there is less space. That's what we mean. In a circle, ratio of arc length to radius is called plane angle. That's clear. In a circle, arc length to radius is called plane angle. Now listen. In a circle, if I draw a circle here, okay. Now I start from here. Which is the largest arc I can draw? Which is the largest arc I can draw? Let me go from here. The largest arc that I can draw, go. This is the largest arc I can draw, and that is nothing but circumference. Largest arc is circumference. So what will you get if you divide the largest arc by radius? Because we know the angle theta is defined as arc length by radius, and the largest arc, we know it is a circumference, that is 2 pi r. You divide it by radius, r and r cancel, you will get it as 2 pi. So what is the angle for the full circle? See, what is plane angle? It is a ratio of arc length by radius, and I am doing this for the largest arc, and I get it as 2 pi, and 2 pi should be like equal to 2 into 22 by 7, or this is equal to approximately 6.28, and theta must be in the SI system radian. So what is the full angle of a circle in radian in our new unit? You know it is 360 degree, but I am not asking about that one. In the new SI system, how much is that? And that is equal to 6.28 radian. 360 degree, your 360 degree is my 6.28 radian. That's what I say. The largest arc in a circle is circumference, then this ratio, then the above ratio will become equal to 2 pi. Then the ratio is 2 pi. And again, this is something I discussed last class. It is the ratio of two similar physical quantity. Which are those two similar physical quantity? Length by length. It's only a number. This is for insight. It should be there in your mind. It's only a number. But it is given a unit called radian. What is the unit of angle? Scientific unit is radian, not a degree. Erase degree, write radian. SI system unit, plane angle is measured in radian. And for one full circle, how much? 2 into pi. 44 by 7 or 6.28 radian. This is important for us. Now, see, you know how much is 1 meter. 1 meter will be something like this much, 1 meter. You know what is 1 kilogram approximately. You know 1 centimeter, you know 1 meter, you know 1 second. So, what is 1 radian? How much is 1 radian? I'll tell you what is 1 radian. I told you just now, right now, that the whole circle, your whole circle, full circle, you know that angle is 360 degree. But now I am telling the full circle has got a value, new value, it's called 2 pi radian. So 2 pi radian is 360 degree. So what is pi radian? What is pi radian? Pi radian will be equal to 180 degree. I just took half of that one. Now if I take this pi to this side, I will get 180 degree divided by pi. This is equal to 1 radian. So I am asking you what is 1 radian. 1 radian is 180 degree by pi. Okay, and if you divide this thing, you can use a calculator or you can use the this is 180 degree divided by 3.14. This will become approximately 57.3 degree approximately. This is what I did here, 1 radian. What is 1 radian? 1 radian is 180 by pi, which is 57.27 degree. And this is something that you will understand later. Okay, don't worry right now, 57 degree something. Okay. Now, how to do this geometrically? How to do this geometrically? If you want to do this geometrically, I'll tell you what to do. Okay, you draw a circle. Say that the radius, was 4 centimeter. Radius is 4 centimeter. Now from here you draw an arc. What is the radius? 4 centimeter. You draw an arc which is also equal to 4 centimeter. So the radius and the arc length are equal. Then join like this. Then mark this as theta. See, arc length equal to radius. Then this angle equal to 1 radian. So I'll tell you again. Draw a circle, select an angle which is equal to radius, and this is arc length and that is also equal to radius. Then this angle will become 1 radian, and that 1 radian is what? Approximately 57.27 degree. This is the definition of 1 radian. 1 radian is the angle created by an arc length equal to radius. 1 radian is the angle created by an arc length equal to radius, and it's equal to 57.27 degree, or this again useful, 180 degree, 1 radian is 180 degree by pi, 180 degree by pi. Fine. So I told you what is 1 radian. Okay. But we are familiar with the degree measure. We know one circle has got 360 degree. That means if you start from here at 0 degree, if I go around here, this will become 90 degree. This line is perpendicular to this one, then this will become 90 plus 90, this gives you 180 degree, plus 90, this gives you 270 degree, plus 90, this will give you 360 degree, then go on. If you go around the circle once, the angle created is 360 degree, and this 360 degree is equal to 2 pi radian. Take half of this. What is it? 180 degree equal to pi radian. Take again half of this one. You will get 90 degree equal to pi by 2 radian. Take half of this one. 45 degree equal to pi by 4 radian. There are popular angles like 30 degree. How to get 30 degree? 30 degree 1 by 3rd of 90. 90 by 3 is 30. So in this side also you divide this by 3, this also by 3. So you will get this as pi by 6 radian. What is 60 degree? 60 degree is 2 times 30, 2 into 30. 2 into 30 is like a pi by 3 radian. Okay, what is 120 degree? What is 120 degree? 120 degree is 2 times 60 degree, 2 into 60, 2 pi by 3. What is 270 degree? I want 270 degree. 270. 270 is 3 times 90. 3 90s are 270. So multiply this by 3. You get a 3 pi by 2. So this is how you convert the popular degree measures into radian. All starts like 360 degree equal to 2 pi radian. And this is shown in the next slide here. Relation between radian and degree. Listen, each slide I am showing in the video will become a note in your notebook. You pause the video, write down this because this is important for you. So this is it, 360 degree 2 pi, 180 degree pi, 180 degree pi, 90 degree pi by 2, 45 degree pi by 4, then you can do everything. And finally 1 degree is pi by 180. So two relations are now important. What is that? Two relations are important now. Which are they? One is 1 radian. 1 radian two relations are important now. One is 1 radian. What is 1 radian equal to? We told you 1 radian is 180 by pi degree, approximately 57.3 degree, approximately. But what is 1 degree? It is a reciprocal of this one, which is equal to pi by 180 radian. This will become important in calculations. Degree, they will give you angle in degree, but you have to do every time you have to convert this into radian. That's what you're going to do now. Okay. From this to the next conversion. Degree, minute and second conversion. Degree, minute and second. This I'll tell you. Maybe you are familiar with the degree, minute and second. This minute and second come in two areas. One, it can be time measurement or it can be angle measurement. So minute can be time or angle, second also can be time or angle. But how do we know which one is? If suppose I say 10 minute, how do you know that it is time or angle? For understanding that one, if it is angle, we will not simply call it as minute, we will call it as arc minute. So minute will become time, arc minute become angle. Similarly, arc second. These two are angle measures. So arc minute, arc second are angle measures. I'll tell you what it is. Okay. I think this is okay. This should be there in your notebook. Now, one circle is divided into so many degrees. How many degrees? 360 degrees. For convenience, 1 degree is again divided into 60 smaller pieces. That is what we call a 60 arc minute. 60 dash means this should be written as read as 60 arc minute. 1 minute, again for convenience, is further divided into smaller 60 parts. So I'll draw 2 dashes here, and this is read as 60 arc sec. Similar to the time division, 1 minute and the other thing, but this is only angle. So what is 1 arc second? 1 arc second is nothing but it's written as 1 double dash equal to 1 arc minute by 60. Just a reversal of the ratio. Okay, and this is equal to 1 arc minute equal to from this one, it is 1 degree by 60. So combining this you will get 1 arc second, 1 degree 60 minute, 1 minute 60. So there is a 60 into 60. So that is nothing but 1 degree by 3600. This is how you convert. Now we need to convert all of them into radian. Okay, listen carefully. First point, 1 degree. We know what is 1 degree. 1 degree equal to, 1 degree. What is 1 degree? 1 degree is pi by 180 radian. and that you can calculate. This will become 1.745 into 10 to the power minus 2 radian. 1.745 into 10 raised to minus 2 radian. This is 1 degree. Now if you want 1 minute equal to 1 degree divided by 60. So this will give you pi by 180 into 60, and this will give you 2.91 into 10 to the power minus 4. I think this is visible, it's minus 4, it's here, 2.91 into 10 raised to minus 4. Now 1 arc second will give you 1 minute by 60. So this is nothing but pi by 180 into 60, that is your minute, divide further by 60, and this will give you the last value 4.85, I'm sorry, 4.85 into 10 to the power minus 6 radian. So I divided pi by 180 to get my radian for degree, then for minute, then for arc second. This is given in this table, and this should be not, it's not a comma, this is a point, a decimal place, 4.85 into 10. In many questions hereafter you will have to know this, so by heart them, because NCERT textbook, I told you about examples in NCERT. The very first example 2.1, chapter 2, first example. What is that asked? Calculate the angle of question A, calculate the angle of, why this blue pen is not coming, calculate the angle of 1 degree. Calculate the angle of 1 degree. B, calculate the angle of one dash is written in the bracket, minute of arc or arc minute. This we know, this is 1 degree, but this is 1 arc. Tell me, what is this? Arc minute, because it's an angle. Third one double dash. What is 1 double dash? 1 arc second. We need to calculate it, and I have done this previously, and we know this is nothing but 1.745. You should tell me minus what? Minus 2 radian, and this is 2.91 into 10 to the power minus 4 radian. Third one, 4.85 into 10 to the power minus 6 radian. There is one way of remembering it, not completely. This is at 1 point something, power is minus 2. This is double the value, 2 point something into power minus 4, minus 2 minus 4. This is 1, 2, double again, 4.85 into 10 raised to minus 6, minus 2, minus 4, minus 6. So in that way, there is an easiness of memorizing it. Of course, this part is not clearly correct, but I say, if you take it as 1.8, 2.8, 4.8, this is roughly okay. Not okay, roughly okay. If you have no other choice, then memorize it like that. So this is the answer to example 2.1. Fine. Happy? This is the very first question in your +1 career. The first question. Okay. Work out again and again. Because these things will become, this is very easy for me, because I have been doing this for years. But for you, this can be difficult unless and until you practice again and again, this will not work. Okay. Am I scaring you? In one way, I am scaring you. Okay. Next point. What is this? What are this? What are this? What are this? This is like, I can say, this is like a star or sun, radiating energy. Okay. Something is radiating energy. So I can say your sun, sun will look like this, sun. This is an electric charge, which you will study next year. It's a negative charge. And this is an electric charge which is positive. I think this last diagram, the last diagram, it tells you that from that charge something is coming out. In how many directions? It's coming in this direction towards you, away from you, left, right, top, bottom, everything. Suppose this charge is my head, then something is coming in all directions. In this case, what is happening? There is a negative charge and something is going in. This is sun, and from sun light is coming in all directions. You know that sun. From my mouth sound is coming only in one direction, not behind. But from sun light is going everywhere, all directions. In physics, many times we will have to explain this, that something is coming in all space around us, three-dimensional space. Okay. For that, we have this thing called solid angle. I'm sorry. We have this thing called solid angle. I told you the previous one we discussed was plane angle. Next one is called solid angle. Don't worry. Throughout your +1 and +2 career, there will be no direct question from solid angle. Next year, maybe in IIT JEE examinations like that level, you may get something related to solid angle. Otherwise, don't worry. If you can by heart solid angle, that is very good. In exam, if they ask what is solid angle, write the definition, that's it. Do not worry about its application. But plane angle is not like that. Very important. I'll tell you what solid angle is. Solid angle talks about three-dimensional space. Plane angle was talking about two-dimensional space. This is talking about three-dimensional space. You see, there is a sphere. From the sphere, a scoop is being taken out. And this conical shape has got an area here. It has got an area here. You can see that, a curved area. Because this is part of the sphere. So it is spherical here. Okay, this area. If you know that area, let us say that area is A, and if you know the radius of the sphere, which is R, you divide by the square of the radius, R square by A by R square. I'll tell you one more point. This area, suppose you measure in centimeter, this area will be in centimeter square. Area will be in centimeter square, and you are dividing radius. Radius is measured in centimeter, but you are squaring it. Again, you are squaring it. So you are dividing centimeter square by centimeter square. So what will happen? This will cancel. So there will be no unit. Only number. Only number. Connect this to plane angle. Plane angle was also a ratio. No unit, only number. This is also like that. This is what we call as, this ratio is what we call as the solid angle. And you know, you are familiar with this notation. This is, not ohm. Ohm is the name of that one in electricity. This is actually the Greek letter omega. It is a Greek letter omega. Omega is solid angle. Solid angle is A by R square. I'll just remind you about the other thing, theta. What was theta equal to? Theta was equal to arc length by radius. Same thing, no unit, only number. This is solid angle, which is area by R square. So again, no unit, only number. So these two are geometrically defined. They don't have unit, but we give them a unit. So this idea. Now what does it tell you? What does it tell you? It tells you, look inside. When you take a scoop out, what is there inside? There is a space, and that is a three-dimensional space. This thing represents that space, the three-dimensional space. Okay, so solid angle represents the three-dimensional space, and that is defined like this. Okay, so solid angle is representing that space here. Okay, look inside, look inside, look inside that space. That will look like maybe something like this, something like this. If I take, okay, this is fine. This kind of a space you can see here. This space is represented in solid angle. Solid angle is representing. So there is some solid angle here. And how to find the solid angle here? For that you will have to assume an area here, closing this. That area should be divided by radius square. That is the definition of solid angle. But mathematically we represent it like this. You can see that one. Okay, see. This is the solid angle. This thing here inside. if you have a small light source here, light here, then you can see light will come like this. Then I will say the light is coming through certain solid angle. And I can increase or decrease that solid angle. Now the solid angle increased. Now if I wind it down like this one, there is a small solid angle. Now the solid angle is small solid angle. Okay. So this thing here is what we call a solid angle. And how is that defined? How is that defined? You remember earlier, though this was the basic definition, we put a d here to tell you that it is very small, and we put a d here also to tell you that it is very small. So same thing is done here. With this omega, I will put a d. D omega. With this area, I will put a d, dA. D omega equal to dA by r square is the definition of solid angle. So in examination, if they ask you what is solid angle, then you have to draw this diagram. Don't worry about this one. You draw this diagram, then write down d omega equal to dA by r square, and this is measured in a unit called steradian. But you always write it as SR. Always write it as SR, steradian. Fine. So that is about a solid angle. Don't worry, this will not come in numericals. Okay, I guarantee. But I'll tell you where it comes. You already know this. Many things you already know. Okay. Now listen, if I could put this back, okay, and I am talking about that area by r square. What is the largest area of this thing? If I make it larger count, the largest area of this thing, the largest area will become the area of the sphere. Largest area become area of the sphere. So if I want to define it again, okay, I said omega is equal to area divided by r square. This is equal to area. What is the largest area of that cone that is possible? That is the whole surface area of the sphere. 4 pi r square by r square will give you 4 pi. Related this to what we did earlier, S by R, largest arc was circumference. We did like this, 2 pi r by r, and we got a value 2 pi. You remember this in the plane angle. Something similar happened here. Largest area is the area of the sphere, 4 pi r square by r square is 4 pi. So I will say about a point in space, all around it. All around a point in space, the solid angle, okay, I will write down here, solid angle. All around a point. Solid angle all around a point is 4 pi steradian. Solid angle all around a point is 4 pi steradian. Okay, now listen. What is the surface area of a sphere? 4 pi r square. What is the volume of a sphere? Volume of a sphere 4 pi r cube by 3. See this 4 pi, see this 4 pi. That is a solid angle. That's why we have that 4 pi there in sphere. Okay. Now going back. Where is that slide? Yeah. Why are we interested in solid angle? Sun is radiating in a solid angle of 4 pi steradian all around. This charge has got its strength, its electric field all around it in a solid angle of 4 pi steradian. This charge is radiating in a solid angle of 4 pi steradian. So solid angle represents what? Okay, listen carefully. Solid angle represents 3-dimensional space. In a spherical region, the ratio of area of a part of the surface of the sphere to the square of the radius is called solid angle. Area of a part of the sphere by square of radius is called solid angle. In examination, if they ask you what is solid angle, whether you understood it or not, this should be your answer. The largest such area is the total surface area of the sphere, then this ratio will become 4 pi and this will be measured in steradian. Again the same point, it is a ratio of two similar physical quantities, so it's only a number. But we have given it a unit called steradian, we write it as SR. So we have completed all units in SI, especially plane angle and solid angle. Be careful, in the next class we will have lot of numericals to be done about plane angle. So before that, come prepared. Which part you should study clearly? This should be clearly studied. Without that, don't attend my class. Okay, bye for now. See you in the next class.